Hello students, and welcome to this next video. So in here, I just wanted to remind you from the last video that again, we're interested in a population, but we can only ask so many people a question or only collect so much data from individuals. So we really need to figure out how do we get this subset of the population or this sample? How do we select that? So what we do is we sample a population. And the most important way to do so is by random sampling. This is the best way to minimize misrepresenting a population with our sample. Now, random sampling is the process of using chance to select individuals from a population to be included in a sample. So what that means is we allow random numbers to select individuals so that we aren't picking them. That's the most important thing. If we are choosing an easy way to collect the information or a simple way to get at data, then we're probably using a convenience sample, and convenience samples are meaningless. Think of just asking your friends a question. It's not going to tell you a lot about people in general. So obtaining a simple random sample, what do? Suppose we have a population of size capital N. So that's just the number in the population. Let's say it's in the thousands. We're going to get a sample of that of size little n. So think little from the big population. So the sample size might be 100, let's say. And what we're going to do is we're going to randomly sample them. And what that means is every single individual in the population has the same chance of being selected for the sample. Then it is truly simple random sampling. Now, finding your samples. There are lots of ways of selecting individuals to study from a population. We're going to stick with simple random sampling, but I will just say the words that you might hear are stratified, cluster sampling is another one, or systematic sampling. And these are just other methods of trying to randomly select individuals or groups of individuals that minimize bias. And we'll be talking about all those forms of bias and errors that occur from sampling. So a simple random sample, again, I can't state it enough. You have a large population and you select a few individuals from that to be your sample. And the easiest way to do that is through a random number generator and a frame. So suppose you have a list of individuals, you number them 1 through 9, then you randomly select numbers. In this case, it was 2, 5, and 9, and that will become your sample. The easiest way to do that is in Excel. And the first chapter in the Excel workbook found in the assignments folder in this unit is what you will walk through to practice generating your own random numbers and selecting a sample from a population. In the Excel workbook, you will be selecting various states from all of the states in the United States. So be sure you go into that. Now, there's only one practice problem for this video. I'll give you a moment to read it. So clearly, we're not going to ask 1.28 billion Facebook users a question. So here it says Facebook uses convenience sampling and surveys the first 200 users who log in on a given day. They collect some information about those individuals and then use this to report back how Facebook users feel about security measures. And the most important question here is, do you think that the sample is representative of all 1.28 billion Facebook users? So of course, the answer is no. And the reason is convenience samples rarely serve as a representative sample because forms of bias are there. So we're going to talk about those forms of bias next to be clear about what is going on here. One thing you might notice is that users that log on in a given day early on are early risers. So clearly they are surveying people who wake up really well in the morning and miss all of the night owls. So that's just a quick reasoning why we might be missing a lot of individuals in this sample. So let's talk a little bit more. Again, convenience sample, you'll know it in the following ways. So one thing that occurs for convenience samples, they're self-selected participants. So if the individuals are willing to engage in it, that willingness will alter the results. And voluntary responses, if they're willing to respond to the questions, can sometimes be skewing the results that you would get. So if you pick up newspapers, to be honest, most polls you read about are often convenience samples or have other forms of bias. And we're going to go through those right now. So dealing with bias is a big challenge in statistics. And if you end up with a huge amount of bias when you collect your data, then the results, again, are meaningless. So this is the hardest part to do. In this course, we're not going to dive too deep on how to avoid bias. We'll be using data sets that already exist that have been collected carefully. But were you to move on into a job where you will be collecting the data, you should really take a next level statistics course to be sure that you don't include bias in your results. So what is bias? It's when the sample is not representing the population. So for some reason, some individuals are more likely to be in it than others. And those individuals, when you scale them up, don't represent who's in the population. So there are three main sources of such non-sampling errors. And what we mean by non-sampling errors is just those that we could try to control. The sampling errors themselves are beyond our control, and we'll get to that. Just going from everybody, a population, down to a sample means there's going to be some errors. No matter how well it represents the population, it's still not going to be the population. But when we're talking about non-sampling errors, these are the ones that we introduce as researchers. So sampling bias. It means that the technique used to obtain the samples individuals tends to favor one part of the population over another. And usually there's an undercoverage. So one group in the population is less represented than others. So suppose you're looking at a political question. If you went to the Republican National Convention and surveyed there, you would clearly be missing anyone who is a Democrat. They would not likely be at a Republican convention, and therefore your sample automatically includes mostly Republicans. So if you're trying to figure out how people in general feel about a political issue, you wouldn't go to one political party to ask the question. And that's just a very blatant example. There are countless more subtle examples of this that we would go over in a more complex course. I'm sure you can think of examples of this on your own as well. Non-response bias is different. It's when we try to include people in the sample, but they don't respond to the survey. This happens the most. And what's interesting is usually what happens is the ages of the respondents differs based on the platform. So then you end up with non-response bias that clearly favors one age group over another. In fact, anything that requires a mail-in survey is more likely to be completed by individuals of older ages, whereas some technology surveys might be more inclined to have younger participants. So you can think of non-response bias in who has access to the survey platform and who might have time to respond, who might not have time to respond. These are all factors that create non-response bias. Response bias is different, right? They do respond, but they might not be telling the truth. And reasons that might happen are the following. The interviewer made an error by asking a question that's too personal, that people don't want to respond honestly about. Perhaps drug use would yield a response bias, where they would downplay how much they actually use because they're worried about the person who's asking it. Misrepresented answers. Respondents outright lie. Again, maybe they want to inflate their salary because they think the person asking is looking for a higher salary, right? Or seeing if they're successful and they don't want to come across as unsuccessful, so they might inflate results. Wording of questions matters too, right? You could ask something like, do you like killing animals to eat? Now that could lead to a response bias, whereas you could ask, are you a vegetarian? So these two questions get at the same result, but definitely in different ways. The ordering of questions matters as well. If you ask a question about whether they approve or disapprove of something, the order in which you ask that might influence their response, and type of question might also influence responses. So if you have what's called a closed question, that means you give them the answers that they're allowed to choose, and that might limit the results because the answer they want to give might not be there. Open is difficult because then you have to look through all of the information in the open answer where they wrote an essay. And even that might create some problems because you might not be able to understand what it is they're saying. And then, of course, last but not least, data entry error. If you enter a 5 versus a 6, you've changed the data. Now, remember I said sampling errors are natural. So the sampling error versus non-sampling error. The sampling error occurs simply because we couldn't survey the whole population. We couldn't get the data from all the population. So by choosing just a few individuals from that, we automatically include some form of error. And that becomes really important to think about when we do inferential statistics. So keep in the back of your mind until we get to inferential statistics that just by selecting a small group of individuals from a larger group, we automatically introduce some error. That's it for us today. I hope this was informative, and I look forward to seeing you tomorrow in our next set of recordings about descriptive statistics.